so we're back to Glowing Telegram, which is this stream/video management project. And hopefully my audio is good. I am unmuted. Good. All right. So yeah, back to Glowing Telegram, this stream management application. Using Docker Compose here to manage our different microservices. We have Nginx as a proxy in front. We have our front ends using Vite and React admin, which is TypeScript and React and CSS and all of those, webby things. And then, right, so last stream, which has been a whole week because I didn't do any of the midweek streams like I did the week before. So last time around, we were working on the silence detection API and made some progress on that, I think, in terms of shelling out to FFmpeg and using the silence detect filter and getting the using a regex to extract the output and these sorts of things. And I was looking at, let's see, so I have somewhere Postman, and there's Docker. So I was just trying to run it with the kind of the sample payload that we had from back before we had implemented anything. And so obviously now this is wrong. We're not passing in any files to detect anything from. But I'm seeing that we are getting an error. I had to add Rust backtrace to set to 1 in the environment variables, even to get this trace. But yeah, so index out of bounds. The length is 0, but the index is 0. Makes sense. So this is in src main.rs line 85. So this is where we're going to start. So as a recap, so we're building this tool for managing recordings of these streams, all of my streams, and management here means a few different things. I actually have README. I use the README as an aid. So we're trying to make it so that I can track the locally record clips from the stream. So clip here just means like sections of videos. Generate a set of episodes from the stream. So like right now I'm manually taking each of these streams and I'm taking the portion of the stream before the midstream break and then the portion of the stream after, and that's 2 episodes. I would like to maybe have either more episodes or kind of condense down things. We'll see. And then being able to transcribe, do speech to text of what I'm saying, and then have a way to review that, to like error correct it, maybe with the help of ChatGPT, and then producing automatic summaries of the episode. So I've already started doing that on some of my latest YouTube videos from the coding streams, where I will just use YouTube's transcript that generates, feed that to ChatGPT, and have it generate a summary. So just kind of like proof of concept of this working. And so I'm going to automate that. And then some other things I was thinking of doing is actually capturing the chat in text form from the stream to have that additional metadata. Then start to do things like flag areas of the video that are interesting, kind of like an automated clip or highlight thing, which is this next part. And then generate chapter markers. So when I'm creating those episodes to upload to YouTube, having it detect taking the identified interesting areas from the episode and maybe generating like chapters in the YouTube video would be nice. And then some like administrative things, being able to archive the videos to like S3, which I've started to do manually because I'm running out of disk space, but I would like to automate that. And then one of the original things I wanted to do with this tool is like take a lot of this metadata and information and then generate something that I could import into my actual video editor, which I'm using DaVinci Resolve, and use that as kind of a start to like do the edits, add effects and stuff, and just like automate as much of that as I can. And AAF is a file format that seems to be generatable and supported by Resolve. So that's the recap of what this tool is and why we're building it. And then last stream we were working on the silence detection API, which, as I just said, a part of what we're trying to do here is to identify like breaks and interesting areas of the video. And to start with, we can do the opposite of that, find places where I'm not talking at all, which admittedly is once I start going on a topic, I'll just yap away for a bit, but there are points where I'm just like pausing and thinking, and I thought it would be good to have an API to be able to detect silences. So that's what we were working on last stream, and it looks like we have some edge cases where we're just throwing in, not even like returning an error, but panicking, and I don't want to panic. So let's figure out what's going on with that. So line 85. Line 85. So here we are looking. I see. Okay. So the way this API is supposed to work is that the API takes a list of. Let me also pull up Postman. Here we go. Put this over on this side. So it's supposed to take a list of identifiers. Let's call them universal resource identifiers, perhaps, but identifiers of the video files. And then it optionally takes a cursor. So we're not providing a cursor here. So when we don't provide a cursor, so when body.cursor is none, then we create this empty started cursor, and it has an index of 0. Now, then what we're doing is we're saying, okay, if we didn't get a cursor, we're going to start with the first file. And what we're going to do is we're going to look at body.uris, and we're going to look at that index 0. But if we didn't get past any URIs at all, then this doesn't work. Now, I have two options, right? Two ways I could, yeah, thanks. Two options for how this could work, right? I could make it so that if you don't provide any files, well, that's an error. Or I could make it so that if you don't provide any URIs, then, well, what is this API? What is this API supposed to return? It's supposed to return a cursor and a list of segments. So if there was no file, then there shouldn't be any segments. Could be a way of thinking about it. So if I wanted to do it that way, I could. Right, and then I also have a to do here. So handle the case where we're at the end of the list. So we probably want to also say, if we get to the end of the list, cursor should be none. That's why, that's right. So during the last stream, I think I changed the type of the response to be, yeah, here we go, detect segment output. So the cursor is optional, right? So if the semantics here are that if we are done, if we reach the end of the files, then the cursor should be none. And so that's what we'll do at some point is implement that. That'll probably be, that's probably, like once we address this one issue where it's panicking, probably the thing to do will be to look at these other to-dos and implement them so that we have a working, like a fully working API. So I kind of like the idea of essentially if you pass an empty list, then we just handle that as, okay, well, there were no segments and there's no cursor, you're done. It means that we don't have a difference of behavior in like calling this API, right? So that means that, because if we have a special, if we say, oh, you have to provide a list, if the list is empty, that's an error. That means whatever is calling this needs to potentially have to have other error checking there. And I think it is still meaningful to say, okay, there were no files, so there are no segments, you're done. That still is consistent with the kind of the meaning of this API. So that is plenty of talking. Let's say if no URI is provided, return an empty list of segments. And if I write the comment, then Copilot will kindly write something that might actually be correct code. Actually, that all pretty much fits if I turn on word wrapping. Oh, okay, let me go a little wider. There we go. There we go. Okay. So if body.URIs is empty, okay, returns true if the vector contains no elements. So that appears to be right. So we construct an output with cursor none, segments is an empty vector. Great. What does that say? The vector will not allocate until elements are pushed into it. I don't know if that will cause a problem or not, but we'll see. So if I save this, and let's see. Can I do, is it silence detection API? Is that the name of the service? So we'll rebuild that. And it's just easier. I mean, granted, it takes, this is definitely slightly longer than just running like cargo build locally. Thinking about that statement. Is that true? I mean, I don't, what else is this doing? What is Cargo Chef Cook doing that's taking so long? Might be worth figuring out. Right, if I come over here, excuse me, if I come over here and eventually PowerShell will load, there we go. And we'll go into silence detection API, cargo build. So it's not instant. Okay, I thought this would be fast. Okay, still that's pretty fast. Whereas this is still running. Okay, it took 79 seconds for that other thing to run. I'm not sure why it took so long. Anyway, given that we have all these different services stitched together, and we have like different environment variables and volumes and this and that. And the other thing, it's kind of more convenient just to be able to do it all inside of Docker. All right, so this should no longer throw an error. Yeah, so now we see, okay, we've reached the end of the things that we're processing, and there were no segments of silence identified, which is what we're going for. Okay, so that's that problem solved, I think. What's the next thing? Well, past me left some to-dos. So right now, oh, you know, so what we should do right now is we should pass in an actual file and have it process it and see this actually working. That might be good. So how do we do this? So the URI, we split based on the slash. And we take the last one. That's probably actually a good thing. That might protect us from some problems later. Okay, so let's say we do something like file : slash, and then I need a file. Hold on, file browser. You don't need to see that. Don't look at my files. Let's see here. I should probably take one from a coding stream. Let's do the latest one. What day was that? That would have been the 3rd. I mean, I have a recording now, but it's 0 bytes because it hasn't actually been fleshed out by OBS yet because we haven't been streaming for 20 minutes. So if I go back to the 3rd, 12/3, 12/3. Here we go. So here's a file name. Get that out of the way. Paste that there. So there might be other stuff here, but it doesn't matter. There's a slash, and it's going to take the last thing after the stuff after the last slash. It's going to put that in the file name, and then it's going to add that to the video storage path, and that might actually work. So what does this do? Ooh. Okay. But didn't find any segments. That's interesting. What do we see in Docker? So in silence detection API, (253 milliseconds). Do I believe it shelled out to FFmpeg and processed the file in 253 milliseconds? Not really. I really don't. If there was an error, it would have returned a 500. Let's do this. Trace output. Does that work? It seems to. Let's rebuild. Let's see if this is any faster now. Not that we've done anything different, but let's see. Oh, all right, that was faster. All right, so the behavior of the API is not going to change, but maybe we'll get some logging. Silence detection. Or not? Did we not get that far? We definitely got a cursor, right? So we... Maybe my log level? Yeah. So in my Docker file, my Docker compose file rather, Rust log is set to debug. I think trace is lower than debug, so that'd be why. Let's do this, and then that should allow me to run just Docker compose up. So now if I send this, maybe we'll see some trace logging. And also we can see more information about what's happened. We can see the traces from hyperproto, whatever this is. This looks like whatever is handling incoming HTTP requests. All right, so now we can see, here's our detect segment endpoint. We can see the URI, and now we can see the output from, so this is all the output from FFmpeg. No such filter duration. So something I've not figured out is how to make FFmpeg, when you use filtering, to say, oh, there was an error. and like return a status, like an error, an exit code that would tell us that there was an error. I think what I might do is maybe look for this message in the output to be able to detect there's an error. I'm going to leave the trace in though, because that's going to be helpful, and I can always turn that off by changing the log level later on. Detect error in filter by looking for an output. All right, so if output contains conversion failed, then return a 500. Copilot once again writing some nice code for, well, some code that probably works. But we should probably fix the problem. And the problem was that I passed silence detect noise equals duration equals like this without actually testing that. Let's see. Do I have an FFmpeg command? Huh, can we not pass multiple options? Hold on, where's my web browser? There we go. FFmpeg silence detect. It's in my history. In equals colon. Aha, I used a comma. So we can use noise equals. Okay, you can say duration or just D. What did we set this kind of default duration? Half a second. Okay, that's a value. So, but it looks like the main issue, wherever it is that we used a comma and we should have used a colon. Okay. I'm gonna put this back this way though, because I want to see that our error checking on the output actually works first. So we'll rebuild the service. Oh, the coffee's almost gone. It's so sad. Okay, so the service is up. And if I go over here, when I send this, I should get a 500 error. Yep, 500. There we go. All right, so now I'll fix the problem. And we should maybe actually get a list of segments. So, fingers crossed. It's good that it's taking longer. This is it running the FFmpeg commands and scanning a 20-minute video, looking for silences. Looking for silences specifically at a kind of a certain noise threshold and for a minimum duration of half a second. So how many half a second pauses were there in a 20-minute section of video? Like that right there could have been one if we were analyzing this video that's being recorded right now, but we're not. We're taking one from a week ago. I see we have some results. So how to interpret this? Are we actually? Hold on. Can I drag this over? There we go. See my desktop background peeking through. So the duration. Okay, good. So, and start and end. Are we doing the same thing where we're properly constructing it from? Okay, good. So these values here are in. There's a standard, an international standard for representing time values. Think like, if you write the date, how do you write it? Do you write it year? Well, most people probably write like month, day, year, day, month, year. I like writing, and the ISO International Standards Organization 8601 standard likes writing it year, month, day. So from largest time unit to smallest, right? And there's a bunch of standards for dates, standards for times, standards for durations, like how long things last for. And so this is an ISO 8601 duration representation. And so this is saying 31 seconds. The S means seconds. The T is a separator. So if we wanted to talk about durations in years and months and days, that would go before the T, as I recall. And the P is just kind of a prefix there. So we have 31.5174 seconds is when the segment ends, and it starts at the order is determined by whatever library is actually, the internals of how it's generating JSON. But so we're saying there was a segment of silence starting about 30 seconds into the video and lasting for about a second, a little over a second. And then there was one 165 seconds in and lasting for about a second. And then, another second. Long pause. And then another second. I'm not very quiet, apparently. Although how many... Okay, there's not that many segments. Hold on, let me... Yeah, there we go. There's the end. So there are... That is interesting. It's kind of suspicious that all the... Okay, this one was... No, it's still about a second. I wonder if our noise threshold is too low or too high. What's interesting about this video... So this one is the first 20 minutes of last week's coding stream. So the first couple of minutes is just silence. Assuming we're looking at the right track, and I think we should be, because we should be using this track value to find the track where I'm talking. Because otherwise, that's one of the nice things about the way I have the video recording set up, is that the audio tracks are separated. So there's a separate track for the music and a separate track for the microphone. So we should be just examining the audio from the microphone. And so that should be the 0th video, the audio track number, or whatever's in track, which is from body.track, which is a 1 here, right? So that should be track 1. So maybe we can adjust the noise values here. I think what I'm going to do, just to make it easier to debug, and maybe, I think I'm just going to change the API to support passing in those values, kind of optionally. So we're going to have a noise. Is it F64? It is. Okay, and a duration. Yeah, exactly. So then what we're going to do is we're going to say noise is body dot noise unwrap R, or could be fine. Or is it unwrap or default? or returns the contained same value or provide a default, right? So we have an option, and we can unwrap it to get whatever value t is inside of it, unless it's none. Oh, hold on, I want to still look at the example. So if body.noise is not provided, it will use the value that we're passing in. So that's what we want to do here, and then we'll do the same thing for body dot duration. So this will allow me to essentially keep the same API I was planning on implementing, but also pass in these values so I can kind of fine-tune what the value should be right now. And if for some reason later down the road I want to be able to adjust those values, then I'll just leave those inputs there for the text segment input. That should have built it. Okay. So now I should be able to pass in a noise value. So if we pass in what we originally passed in, and let's see, duration. 5. Basically, if we pass in the same values, we should get the same result, right? So we should have like 48 lines of JSON here. Last time it took 46 seconds. This, by the way, is why I was planning, and I'm still planning, on building like an asynchronous task API that's going to call this service for us. Because, you know, processing a stream, like if each file takes half a minute to process, then a whole stream is going to be, you know, a dozen or so videos. That's several minutes of processing. We wouldn't want our front end, our React admin, like dashboard UI, to just sit there and make the user wait for that to process. So we will make an asynchronous thing that will handle calling this API repeatedly for all the files and kind of process everything through for us. We see kind of a similar result: 29 to 30, 30 to 31. And we have, how many lines was it before? Is this more than it was before? Oh, it is, because the default was 0, 0, 0, 1. I changed the noise to 0, 0, 1. Interesting. Okay, so let's keep the noise level. So how I think this works isn't I could say, but we could actually just look at the docs. So set the noise tolerance is what noise does. Can be specified in decibels, but we're not doing, or amplitude ratio, right? So the default is 0.001. So that's what we had just passed in, but not what we were using before, right? And then the duration, what if we put the duration up to 2? So now this should be the default value. See, default is 2 seconds that FFmpeg has. So what does that look like if we just do like the FFmpeg defaults? Maybe that'll even be good. Now we have a minute or half a minute's wait. So while that's going, I see a couple people lurking. Hello, thanks for hanging out. I am so close to the 3 average viewers over a 30-day period that I need for this channel to be made affiliate. I think as of the stream on Friday, we're at like 2.89 average viewers. Yeah, hey, there's Foxy Blue. Yeah, so it's really, really exciting. I think you're pretty close too, aren't you, Foxy? You just need a few more followers. See, I did it the opposite way. I got lots of followers, but need to keep that average up. 4 more. Wow, so close. All right. So what did this result? So now we don't have a thing, we don't have a noise or a silent segment at the very beginning. So we are 162 seconds in. That's more believable. That's like 2.5-ish minutes. I don't know. Look, don't ask me to divide at 9 o'clock in the morning on a Sunday. So now we have like 2 or 3 second pauses. That's kind of interesting. I guess if we really wanted to verify this was working, I could pull up the file. I don't know if I have that set up to actually show up on stream, but we can try. This is going to get a little meta. So this was the 12:03, 28. Wee, VLC. On the stream, we will watch a stream. Let's see. I don't think this. Hold on. Now, what I'm hearing right now is the music streamception, right? But I think that is not coming through. Let's see if I switch this to VLC though, and then turn this up. There we go. Can we change the audio track? Hold on, I gotta pause. Pretzel. Oh, interesting. Oh, right. Right. So here's what's happening. So I think the voice track on the recording is not the second track. It's actually the third track, because these have a first track that has the mixed audio, etc. And that's all well and good. That's all well and good. All right. So cool. So that's the problem. So if we switch this track to 2, I'll put the music back on. Come back, Pretzel. There we go. Just a soft background sound. Let's try this now. So this will be the third track, because we're counting from 0. And of course, waiting another minute for it to process. Let's see. So I think as long as we get something that looks kind of reasonable here, yeah. Okay, so that's interesting. 229 seconds is 3.81 minutes. So I think that's actually pretty good, because that's just saying, here's the portion of the video in which I wasn't talking. It's a 20-minute video, but it's the video from the beginning of the stream, where there's like the start screen that I have, where I'm I'm getting ready, and the countdown's going and all that stuff. So I think this is right, and this is a good floor. I may adjust it later, but it's a start, and it should allow us to move on. So what's fun is this is just the FFmpeg filter defaults anyway. And it's just important that we use track 2. Okay, so let's move on. Next thing is we have some to-dos here. Find length of the recording. So right now in the output, we're returning this offset, and we're going to be using that when we process multiple files. So here's an example of what that looks like. I'm not going to actually do this because I don't want to wait another 30 seconds. But let's say there was another generally these are 20 minute long videos, so it would be like that. So it'd be like we pass in like a list of all the files for the stream, right? And what we would do is initially it would process the first file and then would return a cursor, and it would say index 1 and then offset, and this would be a value representing how long the first file was, like how long, like the playtime, let's say. So and the purpose of that would be that when you call this API the second time, you take this cursor value, right, like this, and you pass it in, and then when you run this API, when you like call this API, when you send this request, it looks at the first, the the second, the one indexed file here, this one. And when it returns the values for the segments, it adds this offset to them. That way, all the values that you get back from this API are the start and stop points of the segments in context of the whole video across all the files. That's the idea. But to do that, we need to know what the duration is of the recording that we're processing. So like, how long was this file in seconds? So right now I'm just hard coding a value that isn't the right value, because we're going to come back and do that. So how are we going to do that? Thinking. Furious thinking. First thing I'm thinking about is I think that in our database model for these clips, so here's the representation of like a video clip. I think we have a duration, like how long the video clips lasts. So one option would be to avoid getting the duration, and instead I could change the semantics of the API to say, oh, the segments, the start and ends represent the relative start and ends, right? That is not... How do I feel about that? That's not the worst. Whatever is calling into this API, presumably like through the task API that we haven't built yet, is still going to have to understand the meaning of the data it's getting back. It's still going to have to process it in some ways anyway. So I guess it would not be too bad to ask that client to also, because it already, if it has the URIs of the video clips, it presumably is getting that from the database. It could also get the durations of each of the clips and then do the math itself. I don't think that's unreasonable. Alternatively, I could change the API to, instead of passing in just a list of URIs, we could either have a list of objects or have multiple lists. Probably a list of objects would make more sense. That had both the... So instead of it being URIs, it would be like video clips, and then it would have the URI and the duration of each one, and we would do the math here. But I'm kind of in favor of keeping this simpler. Like the client, like in order to do that, the client would have to have the information anyway about the duration of the files to be able to pass it to us. So why not just expect it to keep it to itself and figure it out itself? Is a way of looking at it. Yeah. Okay. So I've sold myself on this idea of what we're going to do is we are not going to do this bit here. We're not going to find the length of the recording, and we're not going to add the offset that we find to the start and end of each segment. Instead, what I want to do is I want to go back to the README for this API, and I want to make sure the README says what we're going to do, because it's good practice. It's good practice to remember to update documentation when you change things, even if this is only for the future version of myself that will be reading this from the beginning of, I mean, it does say from the beginning of the file until the end of the silence segment, from the beginning of detect segment incrementally detects silence in a file. The API endpoint takes a file URI and an optional cursor. So this is the API that we're working on. The cursor is used to track progress of the detection. Returns a new cursor, a list of silent segments. A silent segment is a segment of the file that contains silence relative to the rest of that file. Segments is a list of silent segments. A silent segment is an object that has two fields, start and end. Start its duration until the start of the silence from the beginning of the provided file. Yeah. And end is a duration until the end of the silent segment from the beginning of that same file. Just to be clear. Although I think the way this was written before covers kind of the use case that we're talking about here. And then we have the detect endpoint, which is kind of it does everything. And it's asynchronous, it returns immediately. Detection happens in the background. Location header, status endpoint. Sure. The result provided at the is not the same, but similar to the result provided, and the each silent segment. It's not a list of lists. It's just a list of silent segments. Each silence corresponds to. Oh no, actually, maybe a list of lists does make sense. Each list of silent segments corresponds to a file in the URI's array, and the start. And it's really great when Copilot just like finishes writing the documentation for me. Sometimes it's even right. End fields of the silent segment durations start and the silent segment from the beginning of that same file. Yep, cool. That is what I wanted to say. That this endpoint is going to do something that's going to produce kind of the result of calling this endpoint over and over again. But each set of segments provided is going to be relative to the individual file, rather than it having some way of knowing how long the files are and like accumulating the relative durations into an absolute duration. Okay, so then it's a great way of completing a to-do is just to not do it and change the definition of what is to be done to not have to do the work, right? Just minimize the work that we need to do. All right, so handle case where we're at the end of the list. So let's get rid of the word to do, and maybe Copilot's going to write this for us. So we're going to say that length is the length of the URIs, and we're going to say if the index, right. So let's imagine this, right? The user calls this API, and let's say there's just one item in the list, right? So then the cursor's index is going to be 0. If we were to add 1 to that, which is what this down here would do, is it's going to add 1 and return a cursor with an index of 1. If we were to have that API be called, like this API is called with a cursor with an index of 1, well, there isn't an index of 1 in our list of URIs, so that would be a problem. So in this case, like length would be 1. Let's take a look at this really quick. So in that case I'm imagining right now, right? So cursor.index is 0, we add 1 to it, now this is 1. Length is 1. Technically we could say something like if cursor.index plus 1 equals length, right? Which it would, right? Because length would be 1, and then the next index would be 1, so they would equal. So we've reached the end, right? Because the next index 1 isn't in the there isn't a second entry in the list in this case because length is 1. So this is the case where we want to return whatever segments we found, but a none cursor to say this is the end of the thing. It is not so bad to say greater than equal to. If somehow we were to get to this, or maybe this case were moved somehow or something, it's definitely true that if somehow cursor.index plus 1 was greater than length, we would definitely also want to stop. But that also reminds me of, or puts forward another case where maybe the cursor is invalid that we get, right? So if the cursor is out of bounds, exactly, return an error, right? So if somehow let's say the user generated a cursor object, like put in a value there, or removed something from the list of URIs or did something else, right? Then we would want to handle that case, right? So we can do that. Another option would be, so when we are parsing detect segment input, we could probably do something like add validation here somehow. I think I've mentioned that a couple of times, but I've not actually done the work of researching how I would do that. So TBD on that. Let me, since I have mentioned it a couple of times, let me go over here to the project. Oh, by the way, you might be wondering, because at the beginning of the stream, I did not, in fact, mention what has changed since the last stream. And the fact of the matter is, I've been so busy the last week that nothing's changed. Nothing, no work was done on this project in the intervening week, which is also why there weren't any streams, because other stuff came up. But, yeah, so I don't already have something about validation in here, do I? Nope, lots of other things that I want to do, but not that. So investigate validation options for inputs for Axum API Certi. Yeah, that should be enough to jog my memory when I see this again. There's a thing about fixing sorting. I think our sorting for our CRUD API is also broken. So I need to figure that out at some point. But anyway. Okay, so this is good. We could probably do some other validation. I'm checking if it's empty. We could. This relates the cursor to that. Right, so the offset thing that's inside of the cursor, we don't need anymore. Which means this whole serialize with and deserialize with, we don't need that. Yep. Alright, what did that break? couple things. Also, this was wrong. Okay. Yeah, we don't need that offset anymore because, of course, we had decided that we're just going to return the relative lengths for the start and end. So we don't need to, like, accumulate the offset either via the cursor, which means this cursor is going to be an object just with an index in it. But that's fine. It's all good. All right, so let's rebuild the silence detection API and give it a little test. Since we are recompiling this and we have the new defaults, right, for the noise and duration, we don't need to pass these in anymore. And we're gonna run this without the cursor initially. And we'll send this, and this will take 30 seconds to process-ish. Ah, 44 seconds that time. Okay, so now it says, okay, if you want to continue, you need to use this cursor. All right, and so we pass that in. So what we have here is we have this first segment of silence from the beginning of the video to 229.607 seconds into the video was just relative silence occurring for, from our noise floor. And then if we process the next thing, that returned no segments. That's interesting. What happened there? Is that file name wrong? It is, but that should have not just produced like a 200 OK. We should have gotten an actual error because the actual file name for the second video was 084630. I see it was. So the first video was like a few seconds longer or something. For some reason. Whoop. Is my internet down, or did the preview crash, or oh, am I okay? OBS says everything is good. The stream preview and the Twitch stream manager is still loading, but I think I'm still live. So, I hope so. I guess I'll keep going. All right, so. Oh, okay, good. What was I saying? Oh, yeah. So, this file name is wrong, but that should result in an error that, here, instead of a 200 OK. So let's look at Docker and silence detection API, and lots of things happened. Okay, so here's our request. Yeah, body, URIs. Yep, track, cursor, checks out, and then it just completed. Interesting. Why? Oh, there it is. FFmpeg output. No such file or directory. Now, I could have sworn, hold on. So if we look at, like we're handling commands error here, right? So if there's an error when running the command, we return a 500 error. But apparently FFmpeg doesn't do something. Executes the command as a child process, waiting for it to finish and collecting all of its output. Unconditionally configure std out, std error handles to be pipes, yada yada yada. This method will return a feature representing the collection of the child processes std out and std error. It will resolve to the output type in the standard library containing those things, along with an exit status representing how the process exited. Errors. The feature will return an error if the child process cannot be spawned, if there's an error while awaiting its status. So do we not get... Okay. I think this might be on me. Hold on. So let's see. Handle output status code. Now, that might be true. Let's see. Does output have a status? Ah, okay. So this is on me for making an assumption here. This error case that we're handling with match is if we fail to like invoke anything at all. Like if the Tokyo process fails to run the command. It's not an error from the command itself. Apparently we need to look at status. So std process output, we have a status, which is an exit status. And then it appears to have a method. Was termination successful? Signal termination is not considered success. Okay. So if status success, do this, else that. Okay, so if it's not a success, then we return an error. Okay, so that's the bit that I was missing. I think what I'm going to do is I'm going to move this down to... after the trace. I'm pretty sure that I did check, and the filter... I mean, maybe my checking was incorrect. But, oh, wait. Oh, right, we overrode the name output here. Okay, well, let's rename this then. So we'll do this, we'll call this command output. And I think I'm going to call this command std error. And this would be command output, just to clarify what's going on here. So that means here in this regex, we are capturing that from command std error. Good. Okay. So let's rebuild and retry. Okay, so postman. So I'll just rerun the same command. Excellent. FFmpeg error because the file doesn't exist. Looks good. Honestly, another thing we should do here is we should use tracing. Yeah. Yeah, if we're going to do that, then I will move this trace down below it. So if the command fails, we'll log the output. And then we'll return. Otherwise, we want to like trace level output that result of the command for debugging. So that all looks good. But we don't need to wait to compile. We'll just, the issue here is that this should be a different name. The actual name was 30 instead of 26. Send. So this should work after, 30 seconds or so. All right, and it detected no silence, which is maybe we can adjust that a little bit. So if we change the noise level, right? So this is the threshold of what is considered like background noise. If we were to lower the threshold. No, increase the threshold. So the default, the thing that we're using right now is 0.001. So if you were to increase the number, that treats, I think that treats more things as noise. And so we should find more relative silences with that value. But yeah, this is why I wanted to leave this as a parameter. It might be useful later down the line, but especially right now, trying to like dial in what good defaults are going to be. Another thing I could do in our API is instead of hard coding defaults, here, right, use environment variables to be able to provide those defaults via the Docker compose config, and so we don't have to recompile to change those. That is probably something else that would be good to do. So I think increasing the value here will eventually result in finding segments. Unfortunately, doing this does mean that we're rerunning that FFmpeg command that takes, a few seconds, like 35 seconds apparently to run each time. Were there any other to-dos left in the main.rs? Well, I mean, I guess there should be to do down here, right? It helps if I press the right key. To do. Implement, yes. Okay, so now it found silences. It found like a 6-second silence here. And a 3-ish second silence there. 2 there. Okay. So it found a bunch of silences. Like 3 seconds there. And it is looking for like silences of like 2 seconds by default, because we didn't override the duration default. So here it found something of like 15 seconds there. So this is kind of believable, and we could tune this further, right? Okay, so I think here's what I'm gonna do. We can't really implement the detect, like the main endpoint, until we have the task API. I don't know if I want to work on that today. We might look at more front-end stuff. Although I did have plans, right, to work on the task API. So we'll see. We got a little bit of time before that break, although I'm getting kind of thirsty. Let's see. Right. So here's a question. Why are we using app state here? I mean, we're definitely using it in other places where I think it, well, we were using it in a place where we were passing around the, like the connection pools to the database. We're not using a database here. We're just passing around this video storage path. I guess it sort of makes sense. Like to read the environment variables in main rather than doing it at runtime, because the environment variables aren't going to change without restarting the whole process anyway. So I think what I'll do is I'm going to expand app state to also have noise and duration kind of defaults. And we're going to read those from environment variables as well. Okay. And then in Docker Compose, for our silence detection API, we're going to provide those environment variables. They're just called noise and duration. Duration 2.0. But we'll make this 4 to match kind of what got us some results. 0.004. There we go. And then over here, we can read, you can say body.noise unwrap or state.noise, state.duration. So now that is configurable at the application level, or the service level, the component level, however you want to think about the relative order of things. And we still need to implement this, but again, we need that task API, and we'll have to like integrate it into this as well to make that work, I think. But we can rebuild everything, get everything going, and in the meantime, commit all of this. So we're gonna add that. I don't need to commit the plans. The README update will get in there, and main.rs. So look at all the stuff we changed just in hour 15. Great. Let's add that to the stage changes and see if Copilot can make a message for us. Yeah, that is not a good message. Segment detection. Silence section detection endpoint. There we go. Well, what do next? We can make the task API. It's going to be a lot of stuff, right? So, and this is where we kind of tie in with Redis. I think I have a step here that involves, let's see here. Let me do this. We'll say implement text endpoint use task API. All the rest of that's done, and we'll take this, and this is now dependent on the task API, so we'll move it down there. So the task API, obviously we need to do like the kind of the boilerplate API service setup stuff, add it to Docker Compose, hook it up with Nginx. Now, unlike the other services, I think what I want to do is I want to mount the API endpoint inside of the CRUD API's endpoint. So let's look at the Nginx config. All right, so right now we have this API records that just proxies to the CRUD API service. And what I would like to do is I would like to have like a we do like something like this that proxies to the task API in one way or another. And the purpose of that is so that in React Admin, in our data provider, the way we have this set up is that we have this oh no, the stream. Okay, well, the recording is going, but the stream has ended. Let me see. Wah wah. Okay, I might need to shut off some things. I'm back. We'll see for how long I'm back. Okay, well, I don't know what I was just saying. Something about the Vite API URL and the front end just having like a single base URL that it works out of, this records endpoint, and everything has to be inside of that for the resources in the React admin front end to work. Yeah, something like that. So to facilitate that, oh, Streamlabs is offline too. Let's fix that. Come back, my bot. Let's see how long the stream stays online this time. I know last Monday when I got the same error, and that happened several times before it stabilized. So we'll see. We'll see. Like how Streamlabs, there we go. Okay, that's fixed now. Okay. So far so good. Okay, so this built, what was it saying? All right, so we can do something like this to inject the, so we do like proxy pass, HTTP, task API 3000, something like that, and then we'll strip off maybe this first bit here, or maybe the whole thing. I don't know. Maybe, like this part, yeah, like that. So we do something like that. And so that we have like what the request coming into the Nginx proxy is going to be like API records tasks 1 or something, or posting to API records tasks. But what the task API would see would just be like a post to tasks. That's what this rewrite will do. So we do something like that. And then I guess I'm just going to start working on the task API. Let me step through the other things. All right, so that's what I'm talking about here with making it work nicely with the front end, kind of embedding the API endpoint inside of the endpoint for API records. That does mean that, of course, if you had an actual tasks endpoint inside of the CRUD API, it would not be reachable, is I think how this would work. And then update the README. Yeah, so it would be changing some of the, might be changing some of the API design for the task API. I'll have to check. And then setting up input and output structs for task APIs. So we have, here's what the inputs look like, here's what the outputs look like. And then we'll test that out just with do nothing APIs. And then we'll have to figure out how to get the task service. We'll connect it both to Postgres and to Redis. Why both? I'm not sure. Does the task API need to talk to Postgres? Like, we want to use Redis. We want to use Redis to be able to coordinate task dispatch. A thing then we do need to also do is actually have a task worker service. Right, so I think this was my original intention, right? Was to have an API that you would call into to queue up tasks, and then we'll have task workers that are pulling tasks off of some kind of Redis data structure, some kind of like pub sub thing, I guess. I don't know that we need Postgres in the mix for this though. Like, if we are already using Redis to dispatch workers, we can probably also store information about tasks there. Was there anything? Let's look at the README for the tasks API, the task API. Okay, so this is what I had written. Yeah, some of this stuff needs to change because it needs to be compatible with React Admin, because we want to like have React Admin. Yeah, I put a to-do here for that specifically. So this is a simple task API that allows you to create, read, so basically CRUD, but for tasks. Tasks are background processes that are requested by one of the other services in the system. The task API is responsible for managing the state of the tasks and for executing the tasks. The tasks are executed by making a request to the target service. In other words, the front end won't call the task API generally to create tasks, although it could, and we could actually expose that. But generally, it will be one of the other services. And so the request here, so a lot of this stuff needs to change. But the idea though is that like we call the this thing that we put a to-do in just 15 minutes ago, this detect endpoint, wherever it is, this detect route, we call that, and it's responsible for calling the task API to create a task that will be then responsible. So the task API will create some tasks, dispatch it to workers, and it will then call back the API that we tell it to, which will be this detect segment, and it will kind of like an inversion of control sort of thing with microservices is what I dreamed up for this. So that's the idea. We are roughly an hour and a half into the stream today. So I think, because I really need to get some water, I'm gonna pause here for just a couple minutes to attend to that. And I'll be back, and I guess we're making a task API. Okay, BRB.